Imagine a world where the speed and efficiency of artificial intelligence AI inference can be dramatically improved. That's exactly what D-Matrix aims to achieve with their groundbreaking Corsair in-memory computing chiplet architecture set to debut at Hot Chips 2025. But here's where it gets interesting. This Corsair isn't the gaming gear brand you might be familiar with. Instead, it's a sophisticated piece of hardware designed to revolutionize AI inference by combining in-memory computing with ultra-low latency interconnects. In the realm of machine learning, every token in a large language model LLM is memory-bound, meaning that all the weights need to be read. To optimize this process, D-Matrix focuses on reaching saturation at moderate batch sizes, allowing for more efficient weight fetches and hitting specific latency targets. Real-time voice applications, which require extremely low latency, are particularly well-suited for D-Matrix's technology. Similarly, AI agents that use multiple small models to accomplish tasks can benefit significantly from this approach. The Corsair Accelerator, D-Matrix's latest innovation, consists of 2 chips, each with 4 chiplets, built on TSMC's 6mm process. Together, these chiplets provide 2 GB of SRAM, making the entire system highly efficient. The Corsair is housed on a PCIe 5.0x16 card, ensuring it can be seamlessly integrated into standard servers. At the top of the card, bridge connectors allow multiple cards to be linked, creating a powerful 16-chiplet cluster with all-to-all connectivity. Each chiplet interfaces with LPDDR5X memory, providing 256 GB of L5X per card. The chiplets are organized into slices, with LPDDR and D2D connections around the edges, along with 16 lanes of PCIe. When 2 cards are passively bridged, they form a 16-chiplet cluster, and up to 8 cards can be installed in a standard server, such as a Supermicro X14, with additional NIC cards for scale-up capabilities. Designed for low-latency batch throughput inference, Corsair supports block floating-point number formats and boasts an impressive energy efficiency of 38 TOPS per watt. The dispatch engine within each chiplet is based on RISC-V architecture, and each chiplet is divided into 4 quads, offering about 1 TB per second of D2D bandwidth. The matrix multiplier inside Corsair can handle a 64 by 64 matrix multiplication with INT8 precision, or a 64 by 128 matrix with INT4 precision. It also supports FP formats with scale factors and structured sparsity for compression, achieving up to 5 times compression. Data flows through the system, accumulating on the fly, before being converted to the desired output format. Memory management is handled by a stash memory that feeds the cores, with each stash holding 6 MB and 2 LPDDR channels per chiplet. High memory bandwidth is crucial, but collective latency becomes increasingly important. To address this, D-Matrix has achieved a latency of just 115 nanoseconds D2D, even when passing through PCIe switches, maintaining a latency of 650 nanoseconds. A closer look at the Corsair chiplets reveals an organic package design. For scale-out fabrics, D-Matrix uses a NIC with a latency of 2 microseconds, enabling the stacking of multiple servers. The software stack is equally important, ensuring that the hardware and its features are fully utilized. Power consumption is another critical factor. At 800 MHz, Corsair consumes 275 watts, while at 1.2 GHz it draws 550 watts. Higher clock speeds reduce efficiency, but not drastically. Performance-wise, Corsair can process output tokens in just 2 milliseconds, even for the massive Llama 3 to 7dB model. Underneath the chip, D-Matrix employs a silicon interposer with capacitors for power reliability. They take it a step further by 3D stacking DRAM beneath the Corsair chiplets, keeping the local memory extremely close. A prototype 3D DRAM test vehicle has been developed, featuring 36-micron D2D stacking, with the logic die on top and DRAM underneath. To ensure the stacked DRAM and logic work together, D-Matrix keeps the heat density below 0.3 watts per millimeter squared, preventing excessive heating of the DRAM. What do you think about D-Matrix's approach to in-memory computing for AI inference? Does the Corsair architecture have the potential to transform the industry? Or do you see challenges that need to be addressed? Share your thoughts in the comments below.